In this tutorial, we'll construct basic ReAct agents using Python, enhancing your ability to create adaptive AI systems ready for deployment.
Did you know that ReAct agents are revolutionizing the way AI systems adapt and respond to their environments? Welcome to our tutorial on building ReAct agents using Python. In this video, we'll explore their importance in modern AI, from enhancing responsiveness to improving adaptability. By the end, you'll be equipped with the skills to construct your own ReAct agents, ready to deploy in diverse applications. So grab your Python environment, and let's dive into this exciting journey. Don't forget to subscribe and hit the bell icon for more engaging content.
Before we dive into building ReAct agents, it's crucial to have a well-set Python environment. Start by installing essential packages like NumPy, TensorFlow, or PyTorch, which are integral for AI development. Ensure your Python version is up to date. I recommend using Python 3.9 or later for compatibility. Consider using virtual environments with virtualenv or Conda to manage dependencies efficiently. Also, configure your IDE, such as PyCharm or VS Code, for optimal performance with plugins for linting and debugging. If you encounter setup issues, check community forums like Stack Overflow for solutions.
ReAct architecture forms the backbone of intelligent agents, characterized by its ability to process data and adapt through feedback loops. Unlike traditional models, ReAct agents dynamically adjust their behavior based on real-time inputs. Key components include the perception module, decision-making unit, and action execution. These elements work in harmony, allowing the agent to learn from interactions and improve over time. Understanding this architecture is crucial for designing systems that not only respond but also anticipate and adapt to changes, a capability highly desirable in modern AI applications. Decision-making is at the core of ReAct agents. Let's implement a basic decision tree algorithm in Python. Start by defining your decision criteria and possible outcomes. Using libraries like scikit-learn, you can easily create and train a decision tree. Integrate this logic into your agent's decision-making unit. Test the algorithm using sample data to ensure it makes accurate predictions. Real-world applications include recommendation systems and automated customer service, where ReAct agents can make efficient decisions based on user interactions. To truly enhance agent intelligence, integrating learning mechanisms is crucial. ReAct agents benefit from reinforcement learning, where they learn by interacting with their environment. Implement this using Python libraries like Gym for simulations and stable baselines for RL algorithms. Train your agents using real-world data to improve accuracy and reliability. Adopt continuous learning strategies, allowing agents to update their knowledge base. Evaluate learning performance regularly to ensure your agents adapt efficiently. This approach not only boosts intelligence but also makes your agents more robust in handling complex tasks.
Testing and debugging are pivotal in ensuring your ReAct agents perform optimally. Implement thorough testing by creating diverse test cases that simulate various scenarios. Debugging tools like PyCharm's debugger or Python's PDB can help identify issues in your code. Use performance monitoring tools to track metrics such as response time and accuracy. Testing is an iterative process. Continually refine your agent based on test results. Remember, a well-tested agent is not only reliable but also more efficient, making it invaluable in real-world applications. Optimizing agent performance is key to getting the best out of your AI systems. Begin by identifying bottlenecks in speed and accuracy. Techniques like model pruning and quantization can help balance these aspects. Efficient resource management is crucial. Ensure your agents run smoothly on different hardware configurations. Leverage AI optimization libraries like TensorRT for enhancing model performance. Optimization not only boosts efficiency but also impacts scalability, allowing your agents to handle larger, more complex tasks confidently.
ReAct agents are transforming industries by enhancing capabilities across various sectors. In customer service, they improve interactions by understanding and responding to customer needs effectively. Industries like healthcare and finance benefit from automated complex processes, increasing efficiency and accuracy. ReAct agents play a key role in predictive analytics, providing decision support with data-driven insights. As AI continues to evolve, future trends indicate a wider adoption of ReAct agents, making them integral in developing smarter, more responsive systems. Congratulations on completing our guide to building ReAct agents with Python. We've covered everything from setting up your environment to optimizing performance. Now it's your turn to apply these skills and transform your AI projects. We'd love to hear about your experiences, so comment below and share your insights. Don't forget to subscribe for more tutorials, and let us know what topics you'd like us to cover next. Together, let's continue exploring the fascinating world of AI.